So here we are, third video. Sorry about that, guys. 5.2c. And we're going to do more on scientific notation, so bottom of page 327. And let's just kind of review here. We had numbers like let's get a really stinking big number, like how many dollars I have in the bank. Okay, decimal is right there, right? So we move it from there all the way to there. Okay, so one digit decimal, non-zero digits times 10, and then we count how many decimal places from there to there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? All right, there will be times when you have a very, very small number. So let's say, for example, we have 0.0000. This is how much money I actually have in the bank. Okay, so this number, because all of our numbers are to the right of the decimal, that means that our number is quite small. Okay, so what do we do here? We again move our decimal place over so it's after the first non-zero digit, like that, times 10. So everything's the exact same. Okay, as far as what we do, we move the decimal no matter where it is in this number or this number after the first non-zero digit and put it there. Put it there. Okay. Then we count the decimals, so we were here and we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we moved over 11. Okay, but the difference is, up here we moved the decimal to the left, and that gave us 18. We moved to the left. This one we moved to the right. Well, how do we let people know that we move the decimal to the right here and to the left here? Okay, to the left here, positive 18. To the right here, we put a negative 11. That just tells you what direction we moved the decimal place. We moved the decimal place to the right. In order for it to go back to where it's supposed to, we have to go to the left, 11. Okay, if you remember, when you have a number line, negative direction is always to the left, right? So, if we have a negative here, that means that our original number has to be, the decimal has to go to the left to put it in the right place. Okay? That's one way to remember the negatives and the positive. I have a heck of a time keeping track of which negative or positive, but it's just memorizing. Whatever way works for you is what you need to use here. Okay, so let's look at 36 times 10 to the negative fourth. So the instructions for example 13 says write each number in scientific notation. It looks like it's in scientific notation, right? The problem is there's not a decimal after the first non-zero digit, so that means it's not correct. Okay, so what are we going to do with this? We're going to write this in scientific notation. Okay, so see what we did? The decimal's there, we moved it 1 over. So 3.6, and how many did we move it over? We moved it 1. That's where this came from. Okay, but we can't forget this. So what we'll do is we'll put this in parentheses and then put 10 to the negative fourth there. Okay? So what we're going to do is we're going to look at the numbers with the bases that are the same right there. We'll leave the 3.6 alone, And since these are multiplied, we're going to add. Okay, I really didn't do anything weird. Well, maybe I did, but I took this 36 and wrote it in scientific notation. And I tagged this onto the end. Okay, this came down here. The only thing I care about is this part right here because they have the base number of 10. And then all I did was added my exponents like I know to do. Okay, so let's do point, let me get a pen here, 0.36 times 10 to the fifth. Change that to scientific notation. 3.6 times 10 to the negative 1, because I move this decimal this way 1, so it's negative 1, times 10 to the fifth. So I have 3.6 times 10 to the negative 1 plus 5, given me that for an answer. Okay? So, yeah, that's shouldn't be too terrible, but they are kind of tricky, aren't they? So, anyway, let's go ahead and look at some of the problem sets and see if we can get some questions answered as we get going with those. Okay, so 1 to 30. You're just taking things like 2x to the minus 3 and simplifying them, meaning getting rid of the negative exponents. So this is going to be 2 over x cubed, and you're done. If you have something like 28, notice the only thing that negative applies to and that 2 applies to is the y. So that gives me 5 over, and we take our y squared and put it on the bottom. 20. Okay, that negative applies to the negative 2 and the 4. So let's go ahead and rewrite this as a fraction, and we're going to take the negative 2 and the fourth and move it down. And because there's a parenthesis here, we leave the parenthesis there. So we get 1 over negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. Okay, or because there is an even number of negatives, the answer is positive. 2 to the fourth power is 16. Okay, so let's jump over to 31. They're just telling you to square x, or to square or take the x and square it. And that one's 9. The next one is 2. And it says, what are we doing? The x. See where it underneath where it says power of 2, it has 2 to the x power. That means whatever's in that left column, we're going to put it as the exponent. So in that first one, the negative 3 is that exponent. So that means we're going to write this as over 1, and we're going to write 2 cubed under 1 equals 1/8. The next one says we've got 2 to the x power. I'm looking at the right-hand column because those seem to be the most difficult. And it says wherever you see an x, put a negative 2 in its place. So that's over 1. So we have 2 squared under 1 equals 1 over 4. So that's looking at number 31. Now let's jump down to 33 through 50. In fact, let's look at 50. Alright, so what do I know first of all? I know that this bunch of stuff and this bunch of stuff are all in the wrong places. So again, I'm getting rid of my negatives first. Okay? Now I can do either 2x to the 15 minus 10 and let me put parentheses here equals 2 to the 5th x to the 5th. 2 to the 5th is 2 times 2 times 2 times 2 times 2, so 32 x to the 5th. Or if you'd rather, when you get to this point, say I'm taking out 10 of those and 10 of those, leaving me 5. And that still gives me 32x to the 5th because it's the same as that there. Okay, so either way, you want to do that. All right, let's look at 51 to 78. And let's look at 76. We have a to the 4th to the 8th. Okay, so let's take each one of these pieces at a time here. And a to the 4th to the 8th is a to the 32nd, 8 times 4. A to the 2 times 5 over a to the 12th. I can combine these by adding the exponents and a to the 12th. Take 12 of those away, 12 of those away, and I'm left with 30. And that's what I get for 76. And it looks like the rest of them there have to do with scientific notation, so I'll leave you alone with those. And that's it for lesson 5.2.